Right, hi everybody. We'll just give it another minute or so, just in case anybody else wants to join. Okay, let's begin. Right, hi everybody. My name's Steve Worswick. I'm the author of the multi-award-winning Mitsuku chatbot. Welcome to another Pandorabots office hours. During these sessions, I aim to give you some tips and tricks for the AML programming language to enhance your own chatbots to make them even more better than they are already. Okay, now today it's all really informal. So if you want to type anything into the chat window, I'll try and answer it on air. If not, feel free to email me. What I would advise is just make your screen maximized so you can see what I'm doing. Now, the topic of today is going to be sets and maps. Okay, so let's start off by explaining exactly what a set and a map is. So I'll just make some new AML for today. I'll call it sets. Okay. Now, I'm sure some of you have probably, if you're used to doing AML already, you'll probably have used the set inside the template. This is slightly different. So we may have said something like, name is I. And we start, yep, hi star. So just see what that one does, just so I can show you. So I'll say, my name is Steve. Hi, Steve. Yep. So what that's done is it's taken the value of that set and made the wildcard equal to a new predicate called name. If we have a look on there, look, see name's equal to Steve. However, that's not what we're going to discuss today. The sets that we're going to discuss actually appears in the pattern. Now, let me show you an example of why we would use something like this. So let's say something like my favorite color is red. Nice choice. Okay. Well, as red, we could have all kinds of different things. So, you know, my favorite color is blue. Favorite color is yellow. My favorite color is green. And my favorite color is black. Yeah. Now what we do there, let's try my favorite color is blue. Nice choice. Yeah, that works. Now, trouble is though, we've needed to do what, 5 categories there just to cope with this. And what we can do is something far easier by creating a set. Now, all a set is just a group of common objects, things that are all have something in common. So let's try a new set. Let's make a set called colors. Okay. Now all it is, it's something called a JSON format, which all it is like a big list separated with commas. So let's try red. The last one doesn't need a comma. Blue, yellow, green, black, and white. Right, so these are our list of colors. Okay. Now what we can say, instead of all this, my favorite color is red and blue and green and all the rest of it, we can simply say, does it appear in our set? So to do that, we'll do colors. Yep. My favorite color is, And then if it appears in this list, blah, 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 it should say, nice choice. Let's try it. My favorite color is black. Nice choice. Yep. So what it's done, it's matched there. You can see where it's matched. My favorite color is colors. Okay, now say my favorite color is purple. I have no answer for that. Why is that? That's because purple doesn't appear in our list. So what we need to do is need a catch-all. Oh, my favorite color is unknown color. This one, interesting. I don't know that color. Oops. Scanning. Right. Okay. So my favorite color is house. I don't know that color. That's right, because it doesn't match our set of colors, and it doesn't. So it drops down just to a normal category as you would expect. Yeah. So as well as that, what you can do is you can refer to colors as wildcards. So let's let's copy this. Yeah, so it's the same as the normal star wildcards, normal star indexes. You know, that's 1, star index 1, so we can refer to it like that. So hopefully, let's try my favorite color is yellow. Nice choice. I like yellow too. Yeah, so it's got the star in there. You see, it's picked it up from there. Okay. Now, what you can do as well. Yeah, so you can just make your own sets. You can make as many as you want. Pandorabots does have some built in. One called number. So you could say something like is number. Oops. So is whatever a number. I like to keep them just in capitals, just so I can tell the difference between patterns and the templates. Yes, it is. And if it's not in our set of numbers, say no, it isn't. Yeah, let's see if that works. Is whatever a number? Yes, it is. Is Apple a number? Oh, it isn't. Yeah. Now you can't see what's in that set, but behind the scenes, it's just anything that is the numerical value will be in that number set. Yeah, and again, you can refer to the inbuilt ones as wildcards as well. Yes, star is a number, so if we try, is 45 a number? What do you think it will say? It says yes, 45 is a number. Yeah. You can also do all the usual stuff, so you can set values to things like that. So we can use template tags in there. Number. That. Number, yes, it's a number. So hopefully, here we go. Yeah, now got a number set to that because we've just set it in there. Okay. You can also do more than one set. So let's make a new set. Oops. New sets. let's pretend we're ordering pizza, so we may want to know the size of the pizza. And in here we'll have small, small, medium, and large. Yeah, so do that. And we'll also say, you know, what toppings of pizzas do we want as well? So let's do another setup. Set. We'll call this one toppings. And let's have I mean, you can make your sets as long as you want, but I mean, just for this exercise, we'll just have 3. So cheese, and I don't know, chicken. Yep. So let's try. I want a something pizza. Yeah. Now, in that, I could be saying I want a small pizza, I want a large pizza, or I want a chicken pizza, I want a cheese. So it's taking both the size and the topping. How do we detect which is which? Easily by doing this. Just make a equal one. Okay, so I want a so I want a whatever pizza, small, medium, or large. I want a pizza. And finally, the catch-all. So let's make the catch-all. What do you mean? I want a toppings pizza. Okay, what size do you want? I want a size pizza. What toppings? What toppings do you want? Right. Let's see if that works. So we should hopefully get them from our size and our toppings list there. I want a small pizza. Yeah, what toppings do you want? I want a chicken pizza. Yeah, what size do you want? And then finally, I want a massive pizza. What do you mean? That's right, because that's not in our set. Now, what we can also do as well, if we can put more than one set together. So I want a oh, I've done it again. Just to using in templates. Right. I want a okay. Well, this time we'll say right up. I want a small cheese pizza. Oops, why has it not worked? Da, da, da. Oh, because I've put an extra typo. Yep, that's better. Yep, so what it's done there is managed to match both of the size and the toppings. No, well, for another session, it's wildcards. So what you can do, I'll just show you briefly what we want to say. Rather than forcing them to say, I want a whatever pizza, you can do things like, can I please have a large pizza with ham? Yeah, coming right up. All it's done there is, as long as the set is mentioned in the input somewhere, which it is, large, ham, coming right up. Okay. I'll just put that back to as it was. So again, you can refer to the wildcards as you would do normally. So we'll say size. That is the first wildcard. Toppings is star index 2. Yeah. So just to prove it's worked, I want a medium ham pizza. Yeah, medium ham. And then you can pass it on to the pizza ordering thing itself. Okay, so that's pretty much set. What I will do as well, let's discuss maps. Now, maps kind of go hand in hand with sets. Let's take our colors set, and we will say something like right, what we're going to do is going to make a little quiz for the bot. Name something that is in one of our colors. So name something that is red, name something that is blue, things like that. Okay, so the bot's not psychic, so what we need to do is to actually tell it what the different things are. So we'll call this one objects. Okay, slightly different from sets. As you can see, there's 2 entries in here. One is the key, so for example, say red, and the next one is the value. What do we want it to say in response? So let's say a ruby. Okay, now let's make, I think we had about 6 of them, so red, blue, yellow, green, black, and white. Okay, so let's think of something, something that's blue is the sky, something is a lemon, green, grass, black, coal, and white can be snow. Okay. Show you how that works. Right, let's get rid of the pieces. Oh no. Right, so name something that is colors. Okay. So say how about, right, and then you need map name equals what's the name of your map. So ours is called objects. Yep. I want to say it. Let's just forget that for now. So name something that is red. Yep. How about, and we can say red. Let's try that. Name something that is red. Yep, a ruby. How does it know that? Because all it's done there is it has looked at a map of objects, looked up red, and red maps to a ruby. Yeah. Name something is red, does it in there. Okay. Not very useful, so what we need to do is put the wildcards in there. Let's try that. Name something that is blue. How about the sky? Yeah. Something that is white. Snow. Yeah. However, if we say name something that's purple, no idea, because that's not on our list. Yeah. So what we need to make sure is that we're only picking out colors that we know about. Yeah. So what we need to do is to have a catch-all. say something like okay, try that. Yep, so name something that is green. About grass. Name something that is purple, which is a colour that it doesn't know about. There you go, purple paint. So you can catch it all like that. And that's maps. So again, you can have as many maps as you want. There are some built in. One of the most useful is one called successor and predecessor. All these can be found on the documentation tab. So let's have a look. ML reference. Down to set. Yeah. There was some explanation there, pretty similar to what I've just done there. So it's got the built-in set of numbers. Yeah. The maps one, these are pretty useful, especially the maths ones. AML's famous for having no maths ability. So you can do that in here yourselves. So let's show you an example. Back to our code editor. Okay, let's try. Okay, we'll insert a new category. What number comes after whatever? Okay, we can use a built-in map for this. Map name equals successor. And we want star. So all this is let me show you. Test. Yep, so all successor is you can't see this, it's all it's a built-in map, as I say. So let's try something like that. Kind of like this. So let's just try it with ours. Back to sets. Yep. What number comes after star? I'll look down for star and tell you the number that comes next. Let's try it. What number comes after 3? Oh, yeah, because it's in our test set there. But we don't need to make a huge list of numbers because, as I say, Pandorabots has already done that for us. So we can put successor. What number comes after 999,000? Yep. Built-in map, really, really useful. There's predecessor as well, which tells you the number that's come before it. Now, what you can do with maps as well, you can also loop around. So here's one I've set up earlier. So there's a category that says count to whatever. Okay. So we start off counting in this one at 0, and we want to stop when we reach the target. So the target is the value of star. Yeah. So for each of these, oops, goes on the count loop, which is just a pattern that loops round and round and round, increasing the count by 1 until it eventually equals the target. Let's show you that in action. Count to 7. Yeah. Count to, I don't know, 51. Yeah, and so on. Now all it's doing, as I say, it just sets the counts, which with whatever value comes next, whichever number comes next in the sequence. Yeah. Now just be aware that it's not looping, it's just straying around. So if I put something like count to 3,000, it's going to come up with a recursion error. But it's handy as just an example. That's sets and maps. Well, the only other thing to tell you about sets is that at the moment, if you was to say, I want a pizza that doesn't exist, like I don't know, what did we have? I don't know, pineapple or pepperoni. You can't actually see the contents of the set. If someone is saying, let's have a look. I don't know, chili pizza. What do you mean? Yeah, we can't see what pizza or what toppings do you have? Yeah. No way of knowing. So you can't query the sets at the moment. So, but we're hoping the AML Foundation, we're going to put a proposal together to be able to query sets, to add things to sets, to pick a random set, a random entry from a set. So, for example, we could say, where are we? Name a random color, and it just picks one out of this list. At the moment, you can't do that. You can't actually query what's inside the set. That's coming next, and I'm going to make it even more useful then. So let's go to sets. I think that's probably about it, really. As I say, if you've got any questions about them, just let me know. Probably via email now, because it's probably going to sign off now. But yeah, your sets and maps, AML reference is always there to help you with anything. And yeah, thanks for joining the session. See you at the next one. Bye now.